Yeah, I think as a starting point, what's important for everyone to understand is we like to use the analogy that an SBOM is like a nutrition label for software. And the challenge with that analogy is you can look at a nutrition label in a very small little box and get an understanding of what all is in there. The ingredients list is hopefully just a few ingredients depending on what you eat. If it's a lot, very refined piece of food, it might be, let's call it 30, 40 ingredients in your food. An SBOM has thousands of ingredients in it. It has thousands of entries and complex dependencies within that. So actually giving an SBOM to a human and saying, look at this and tell me whether this software is secure or insecure, where there's problems, it is really hard to do. It's actually a machine readable format, and you can load it up into platforms like the Finite State platform, and the platform will review it and it will try to highlight the issues that you should look at. But the reality is it's a very complex and large piece of data to work with. AI actually is pretty good at those sorts of problems. So if you say, scan this SBOM, tell me what I should do to improve the security of this SBOM, an LLM can give you an answer to that question very, very quickly. Whereas a human might need to dig through that data for a while in order to come up with that answer. So I think that there's a lot of good opportunity for SBOM review, and most importantly, this kind of triage and remediation workflow. So I can scan something and get an SBOM, or I can ask my supplier for an SBOM. What do I do next? Like, my goal is to either be compliant or make my product more secure, or hopefully it's both of those things, right, at the same time. And to do that, I now need to look at this data and say, how secure is it? Which of these vulnerabilities do I need to go check further? And what do I want to do to fix it? And that question of remediating or fixing vulnerabilities is the most time-consuming piece of any sort of product security program. Your engineering team has to go fix things, but where we do see a lot of upside for LLMs, again, is in knowing how to upgrade something in a way that will minimize the impacts on your software, how to fix a vulnerability, where looking throughout your code base and saying, here's exactly where you need to change this, and this is what you should change. All of those are very possible today. And that's where we're investing a lot of our R&D at Finite State right now, is making sure that we can solve those problems at the scale that LLMs can operate and at the speed that modern engineering teams are expecting, because they're using LLM tools as a co-pilot, for lack of a better word, in their development kind of on a daily basis. So that's really where we see the biggest impacts today.